Welcome back. Well, I just hopefully we together figured out correctly that the total time in the air is this initial velocity in this direction divided by 10. Right? That's our total time in the air. And now, how far is the object going to go? Well, it's going to go. Our displacement or our distance in this x direction is going to be, so we could call it distance and the x direction, is going to be equal to Vx, this Vx, times time in the air, right? Times this number. And that's just because, and this is the average velocity because it's not changing, right? This is a constant. Assuming we have no friction or no air resistance is really just a form of friction. The horizontal component of this velocity is going to stay the same the entire time. So the total distance traveled is going to equal this number. Let me switch back to that purple so you know what I'm doing. V sub I square root of 3 over 2, right? That's this, times the time in the air. Well, the time in the air is this, times V sub I over 10. So the distance total traveled, let's multiply this. Vi squared times the square root of 3, all of that over 20. So now we know as a function of our initial velocity in this direction, how far is this thing going to travel? Well, we know that we want it to travel exactly 100 meters. So we just set them equal to each other. We say 100 is equal to Vi squared times the square root of 3 over 20. And then we can multiply both sides times the inverse of this, right? We can multiply both sides by 20 and divide by the square root of 3. So we get V sub I squared is equal to, let's see, 20 times 100 is 2,000 divided by square root of 3. So it's 2,000 times the square root of 3. And so our initial velocity we need to shoot this thing at is going to be the square root of this. So initial velocity is going to be the square root of 2,000 divided by the square root of 3. So let's figure out what that number is, just to give us a sense of whether this just feels right. So let me take the square root of 3 first. 3 square root. Then let me inverse that times 2,000. That equals 1154.7, and now I can square root this. 33.98. So almost 34 meters per second. So my initial velocity has to be 33.98 meters per second for me. So my initial velocity has to be 33.98 meters per second to exactly hit this target 100 meters away. I think that is fairly cool. And we could also do it to figure out, we could do it backwards to figure out, if we know exactly what our velocity is going to be, right? Because maybe like a slingshot always has the same velocity, and the only thing I can change is the angle. As long as we know our inverse trigonometric functions, we can actually figure out the exact angle that we have to aim the slingshot or the catapult or whatever to hit the target. So I don't want you to go out and raise your own army and whatever else, but if you have to, you now know how to command artillery. With that, I will leave you, and hopefully you will not do something overly destructive. I'll see you soon.